Okay with it. Write a new topic. We can start the others now. The next topic is kinetic energy per unit volume. Kinetic energy per unit volume. Kinetic energy per unit volume. Okay. Okay with it. You know how to find how to determine kinetic energy. Kinetic energy is equal half mv square. Half mv square. Okay. Kinetic energy per unit volume means if we consider about a fluid, actually we cannot define a mass. No, if we consider about a fluid, we cannot define a particular mass because fluid is a we cannot get a specific value of mass for a fluid flow. Therefore, in fluid flow, we actually instead of mass, we can use volume. Therefore, instead of mass, we are defining kinetic energies for unit volume. So this is the kinetic energy. Kinetic energy per unit volume means we have to divide each side by volume. So if we divide each side by volume, kinetic energy over volume is equal half m over volume into v square. Mass over volume. Mass over volume. What is the physical quantity? Mass over volume is density. No? It is density. Therefore, kinetic energy per unit volume is equal half rho v square to the rho v square. This is equal density. Right? This is equal density. Therefore, instead of mass, we can use density here. Density instead of mass, we can use density here. Kinetic energy per unit volume. So, what is the reason for defining this physical quantity? For a fluid flow, if you consider about fluid flow, we cannot define a specific mass because it is a fluid flow. Therefore, we are defining kinetic energies, potential energies per unit volume. Okay. Okay. You can write that one. Kinetic energy per unit volume. Right under that. Right under that. We cannot define a specific mass. We cannot define a specific mass. We cannot define a specific mass for a fluid flow. We cannot define a specific mass for a fluid flow. Therefore, we can consider, therefore we can consider volume instead of mass. Therefore, we can consider volume instead of mass. Right. Write down this. Okay, then the next topic is potential energy per unit volume. 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 Okay. We know how to calculate potential energy. Eh? Potential energy is equal. Potential energy is equal mgh. mgh. Eh? mgh. Potential energy is equal mgh. And so if I divide both sides by volume, then m over volume, mass over volume into gh. Okay. Okay. I can write it as this. Okay. Mass over volume, again, mass over volume is density. This is equal density, density is rho. This one is equal density. Density is rho. Therefore, potential energy per unit volume. Potential energy per unit volume is equal rho GH. Rho GH. Actually, it is very easy to remember because we know how to calculate kinetic energy and potential energy. It is they are equal half me squared and mgh. To calculate potential energy and kinetic energy per unit volume, you have to divide that value by volume. Then you will have density instead of volume.
So does that mean that the Bernoulli's equation is the fluid version of the equation of mechanical energy conservation?
Yes, I will explain that. Okay, I will explain that. Bernoulli equation is actually there is not a specific theorem that is about conservation of mechanical energy.
Understood, sir.
Okay. Okay. Potential energy per unit volume. Actually, we have discussed two things. One is potential energy, kinetic energy per unit volume, and potential energy per unit volume. This is potential energy. Before this one, we have discussed kinetic energy per unit volume. So you have to leave that much of a space. I will explain it again. Potential energy is equal mgh. Then you can divide both sides by volume. So if you divide by m over volume, mass over volume means density puthe, density is rho. Therefore, potential energy per unit volume is equal rho gh. So instead of m, now there is rho. It's okay, no? Because mass over volume is density, therefore density can be used instead of mass. Okay. Then then the next topic, Bernoulli's equation. Next topic is Bernoulli's equation. Bernoulli's equation. Sometimes it can be expressed as Bernoulli's principle. Okay. Okay. We can consider a flow tube. A flow tube means fluid flow. And this. Consider fluid flow. So this is a flow tube. Okay, to this direction, fluid flows. Okay. Now tell me, what is the reason? What is the reason to occur a fluid flow? So what is the reason?
Sorry, sir, could you repeat the question?
So what is the reason to occur a fluid flow?
Is it a pressure difference?
Not potential energy difference, but the pressure difference. Okay. As we discussed earlier, in fluid static, we know if the pressure is constant, then there's no fluid flow. But if there is a difference in pressure, then fluid will flow from higher pressure position to the lower pressure position. Okay, therefore pressure difference occurs a fluid flow. And therefore that is the reason. Therefore, suppose the pressure at this place, we can consider a unit volume. At that location. This is a unit volume. Okay. Suppose this length is x. This one is y. Okay. Then now this unit volume flows along this streamline to this location. Okay, you know this location has some higher cross-sectional area. Therefore, its thickness has to be reduced. Okay. Suppose this length is y. This area is A2. This area is A2. And suppose the velocity at this position is V1. At this position is V2. Okay. Pressure at this position is P1. Pressure at this position is P2. Okay. Right. Then, now consider, now this is a fluid flow. This is a fluid flow. Therefore, as this is a fluid flow, this fluid flow is occurred due to the pressure difference. Due to the pressure difference. And therefore, the pressure difference in between these two locations. Suppose this location is A and this location is B. The pressure difference in between point A and point B occurs as fluid flow. Okay. Listen to me very, very carefully. Listen to me very carefully. Okay. Initially, this fluid is at a stationary condition. Okay. And once we apply a pressure difference, now the fluid flows from here to here, from here to here. So at that position, fluid has a velocity v1. At this position now, velocity v is v2. Okay. So due to this pressure difference, now this unit volume of this fluid, this fluid element. Now, if you consider about this fluid element, now it has a potential, kinetic energy. No, it has a kinetic energy. Initially, it doesn't have a kinetic energy, but after applying this pressure difference, due to this pressure difference, now there is a fluid flow. Due to the fluid flow, fluid particles like this. Now they have a kinetic energy. Okay. That is number one. Then this is a flow. So as this is a flow, flow can be so as this is a flow, the altitude or height from the ground can be changed. It can be changed. Maybe changed, maybe not, but it can be changed. No? So if the height from the ground is changed, then what will happen? Then not only the kinetic energy, but also the potential energy of this fluid particle can be changed. Okay. Suppose this is the ground level. Suppose this is the ground level of potential energy 0 level. So due to this pressure difference, two things can be happen. What are those two things? Suppose the initial height is h1. Final height is h2. So due to the pressure difference which is applied on a fluid, if a pressure difference is applied on a fluid, then fluid will flow. So if there is a fluid flow, those fluid particles will have a kinetic energy as well as a potential energy. Okay. That means these fluid particles are given energy, an energy. How to do energy? Who is given that energy? Actually, fluid particle is given that energy. Who gives? Who gives that energy? How to do it? Can anyone say? Give the answer.
Sir, I lost connection for a moment. What's the question?
Okay. This is the question, Pute. Now, initially, this fluid element in a stationary condition, if there is a stationary fluid, the fluid element is in a stationary condition. So after applying the pressure difference, now there is a fluid flow from here to here. So due to this fluid flow, these fluid particles have a kinetic energy. No, initially they doesn't have a kinetic energy. They don't have a kinetic energy. Initially they were at stationary condition, but now they have kinetic energy. So as this is a fluid flow, the height from the ground level can be varied. So due to this variation, the potential energy can be varied. That means due to the fluid flow, the kinetic energy of that particle can be varied as well as potential energy. Okay. So that means there is a work done on that particle. No, there's a work done on that particle. So due to that work done, the kinetic energy as well as the potential energy of that fluid particle is changed. Okay. My question is, what is the reason and what is the factor that change that kinetic energy? Kinetic energy and potential energy. What is the factor? Who did this?
Rho GH.
Rho GH. The Now tell me again, what is the reason? What is the reason or what is the factor behind the fluid flow?
The pressure difference.
Pressure difference. So due to the pressure difference, fluid flow occur. So due to that fluid flow, then there is a energy change or energy conversion. Conversion means initially it has kinetic energy and potential energy. Now it has different kinetic energy and potential energy, but the total energy should be conserved. And, but now there is a work done with it. This work done is done by the pressure difference. Due to the pressure difference, due to this pressure difference, there is a external force. No, due to the pressure difference, definitely there is an external force with it. So, due to this pressure difference, definitely there is a work done on this fluid particle. So, due to this pressure difference, there is a work done on this fluid particle. So, what is the work done? So, due to this pressure difference, the kinetic energy is changed. Not only kinetic energy, but also potential energy of this particle is changed by this pressure difference. Therefore, this pressure difference did two works. What are the works? What are those works? It changed the kinetic energy plus it changed the potential energy of that fluid particle. Did you get my point?
Yes, sir. Sir, I have one small question. Does the kinetic energy change because since P equals to FV and since the greater pressure will have a greater velocity, and is that why the kinetic energy might change at the 2 points at V1 and at P1 and P2?
Yeah. Because according to the as this is a streamline flow, and we can apply equations of continuity. So according to equation of continuity, now there is a small cross section area now. No. Your question is another one. The question is another. You ask if the pressure is high, velocity is low. When the pressure is low, velocity is high.
No, sir. Oh yeah, something like that. That doesn't make sense, no, sir. Pressure
No.
high, velocity low.
No, we can explain that scenario after proving the Bernoulli's equation, but that is not the reason to change the kinetic energy. That is not the reason for changing the kinetic energy. Kinetic energy change kinetic energy is changed due to the pressure difference. So if there's a pressure difference, definitely there is external force with it.
Yes.
There's external force. Now we cannot draw the external force direction here, but there's external force due to the pressure difference. So due to this external force, that external force can do a work on this particle. Okay. That pressure difference. So that pressure difference create the external force. That external force do a work on this particle. Due to that work, this particle flows from here to here, and its velocity is changed. Its potential energy also is changed by that force. Therefore, due to the pressure difference, there is an external force applied on this particle. So due to this external force, its velocity and its kinetic energy, that means its kinetic energy and its potential energy will be changed. Okay. So that is the reason for changing kinetic energy and potential energy. Therefore, there are two works done by the pressure difference. What are those two works? It changed the kinetic energy as well as the potential energy of the particle. Did you get my point?
Got it, sir.
Okay. So this is a fair condition to it. Sometimes you can think how to change the height. If the fluid flows in horizontal may flow, height is may not going to change. No? You can think, no? Yeah, it's a specific case. It is a specific case. So I'm going to prove Bernoulli equations for any case. Okay. Therefore, fluid can be flow on a horizontal line, on a horizontal flow. Okay, that is okay. Then there is there is not a potential energy difference. Okay, but we have to prove these equations for any case. That's why I choose this scenario. So in this scenario, not only velocity but also height is changing. Okay. So due to this change, kinetic energy as well as potential energy is changed by the pressure difference. You can write the topic Bernoulli's equation, then draw this diagram quickly. So this is a flow tube, Pute. We call this as a flow tube. Actually, I have drawn a streamline here. Okay. I will give you the reason. To draw this kind of line. Okay. Have you finished? Okay, write on this. Write on this. Okay. Fluid flow fluid flow occurs fluid flow occurs due to a pressure difference. When considering when considering when considering when considering when considering a unit volume of a fluid. When considering a unit volume of the fluid, the pressure difference the pressure difference forces changes in kinetic energy and potential energy of that unit volume. Pressure difference causes changes in kinetic energy and potential energy of that unit volume. Right. Okay. Okay. Marlon, please look at the board. So if we consider about an object, if I apply a force, on this object, and suppose this object moves x direction, x में So if I apply a force on an object, and suppose initially this object is at zero velocity. Now the velocity is v. Velocity is v. Suppose the travel distance is f. Now, you know the work done by the force F is equal to Fx. So there is a work done by this force F. So what is the work? I'm not asking the magnitude. I'm asking what is the work done by this force? What is the work done by this force? You know the amount is Fx. I'm asking what is the work? What is the work with it? So what is the work done by this? Yes. Initially, this object is in stationary condition. Therefore, it did not have the kinetic energy. But after applying this force, this object has a velocity of v. That means it has a kinetic energy. Therefore, work done by this force, now it is in the form of kinetic energy. Neda? මේ force එකෙන් කරපු work done එක දැන් මෙයා ගාව තියෙන්නේ kinetic energy එකක් විදියට. Okay. Therefore, work done by the force is equal to the changing kinetic energy. That is energy conservation. That is energy conservation. So work done by the force means now energy is supplied or energy is provided by this force to this object. Now energy is provided. How much energy? F into X. That is the amount of energy provided by the force F into X. Now that energy is in form of kinetic energy. Therefore, kinetic energy of this particle should be equal to the work done by this force according to the energy conservation. So according to the energy conservation law, energy conservation principle of energy conservation, work done by this particle by this force should be equal to the change in kinetic energy. Okay. Now, therefore, we can apply energy conservation law to find change in kinetic energy or find the final velocity. Did you get my point? That is energy conservation. Malki, Rashini, did you get my point? Okay. Again, name Marlon Pathirage. So this is the force exerted on this object. So if I apply this force and if I travel this object x distance using that force, the work done by the force is equal to Fx. That work done is stored on this object as a kinetic energy. Therefore, increased kinetic energy is equal to the work done by that force. So same thing can be applied to this scenario. So you have to find the work done by the pressure difference. The amount of that work done should be equal to the change in kinetic energy plus change in potential energy. Therefore, if I apply equations, well, the principle of energy conservation, I apply principle of energy conservation. I can say work done by pressure difference. The work done by pressure difference is equal to the change in kinetic energy. Change in kinetic energy plus change in potential energy. Did you get my point? පැහැදිලිද? මේ work done එක කවුද? මේ pressure difference එකෙන් කරපු
Got it,
work
sir.
done එක. So yes, do you have any questions with it?
No, sir, I said I understood it.
Okay, thank you then. Okay, that means work done by this pressure difference is equal to the change in kinetic energy plus change in potential. And this is energy conservation. Okay. Have. You can write these two. Principle of energy. If you want to draw this one, for the explanation procedures, you can do this one separately. We don't want another garment. Explorations procedures to have බැරි වෙලා හරි පස්සේ යමතකුවත් කොහොමද මේ වුනේ කියලා මොන පැත්තක ඇඳලා තියාගත්තට කමන්නේ. Shall I erase? Okay, I need responses from everyone. Do you get my explanation? This one? Thank you. Marky? Bernoulli? Okay. Shall I erase? Okay, now this is the best part. Okay. Everyone, please listen to this very, very careful. Very, very careful. Work done. Is equal to force into distance. Force into distance. Is equal to force into distance. Okay. In the last part. Force. Force can be written as pressure into area. Force can be written as pressure into area. No, Pute. Pressure is equal force over area. Force over area. Therefore, force is equal P into A. P into A. Therefore, work done is equal force. Force can be written as pressure into area. Pressure into area. Pressure into area into distance. Look at this one. Look at this one. Area into distance. Area means this A1 area. A1 area. Okay. So distance means this distance. And area means this one. Distance means this one. Area into distance mean that volume putting. That volume. So area into distance, area into distance means volume of that particle. Volume of that particle. Okay, you can take any volume. Area into distance means volume. Area into distance. Okay? Area into distance. A into distance. That means volume. Therefore, this one is equal to volume. This one is equal to volume. So work done is equal pressure into volume. Pressure into volume. Okay. Now, this is the best part. Now you can divide both sides by, or you can take this volume into this side. So, look at this one. Work done over volume is equal to pressure. Is equal to pressure. Work done per unit volume. Work done per unit volume is equal to pressure. That means work done on unit volume is equal to pressure. Is equal to pressure. And therefore, work done in a unit volume on a unit volume is equal to pressure. Very, very, very interesting one. Work done on a unit volume is equal to pressure P. Very, very interesting derivation this one. Therefore, instead of work done, that means F into X, I can use pressure. I can use pressure because that is equal to the work done on a unit volume. Did you get my derivation and explanation? Everyone, I need responses. Malki, Rashini, Hari. Tevand Gute, Malki. Hari. එහෙනම් ලියාගන්න තියෙන්නේ. මේක ලියාගන්න තියෙනවා. ලියාගත්ත ටික දිගටම කන්ටිනියු කරන්න. work done කන්ටිනියු කරන්න බං අර. මේක එක දිගට ගන්න පුළුවන් නම් හොඳයි නේද අර බෝඩ් එකේ තියලා. බෝඩ් එක ලොකු වැඩක් නැහැ මේ. එක කැමරා බොන් කෙනෙක් නැහැ. හරි. ඔය නිසා මේ ටික තමයි යූස් කරන්නේ. Work done is equal force into distance. Pressure is equal to force over area. Therefore, force is equal to pressure into area. So instead of force, I can write pressure into area. So work done is equal pressure into area into distance. Area into distance, when we are when we were deriving volume flow rate, that is A into V, that is area into distance. So area and distance means volume. That is volume. So work done is equal to pressure into volume. So if I divide both sides by volume, work done over volume is equal to pressure. Work done over volume means work done per volume. That means work done on a unit volume is equal to pressure. මොකද ඉස්සරහට ඔයගොල්ලන්ට මේක හොඳට මේ හොඳට තේරුම් ගන්න ඕනේ කියලා කියන්නේ Bernoulli equation එක සමහරවල් ඉස්කෝලේ ඉගෙන නැති Bernoulli equation එක කියනකොට pressure plus මේ half rho v square plus rho gh නේ තියෙන්නේ. හරිද? දැන් එතකොට ඒක කොහොමද energy conservation එකක් උනේ? අතන තියෙන pressure එකක් නේ. කියලා හිතෙන්න පුළුවන්. pressure එක plus ඊළඟට ඒකට එකතු කරලා තියෙනයි. මේ kinetic energy එක ආයි එකට එකතු කරලා තියෙනවා potential energy එක කොහොමද අපි unit and dimensions වල අපි ඉගෙන ගත්තා මේ මොනවද මේ අපිට add subtract කරන්න පුළුවන් same මේ physical quantities විතරයි කියලා කොහොමද pressure එකක් energy එකට එකතු කරන්නේ pressure එකක් කොහොමද energy එකක් වෙන්නේ අන්න ඒකට reason එක තාපුද අන්න ඒකට reason එක තාපුද pressure means work done on a unit volume. Okay. Did you get my point, everyone? Have you? Okay. So once you complete writing, please let me know. Once you complete writing, please let me know. Okay. All right. Okay. So if we consider about this unit volume, okay, work done at point A is equal to P1, no? Because pressure is P1, no? Because pressure is P1, therefore work done at point A is equal to P1. Then work done at point B is equal to P2. Therefore, work done due to pressure difference is equal to P1 minus P2. Work done due to the pressure difference is equal to P1 minus P2. Did you get my point? Therefore, work done at point A, work done on unit volume work done on the unit volume at point A is P1. P1 kilo work done है So P2 kilo work done है එතකොට pressure difference නිසා වෙන්නේ done එක වෙන්නේ P1 minus P2. P1 minus P2. And did you get my point? තේරුණාද? ඉරිෂිත? අශිනි? සේනදි? Work done on unit volume at point B is P2. Then I can write work done, total work done due to pressure difference. Total work done due to pressure difference is equal P1 minus P2 is equal P1 minus P2. So due to this work done, two things, uh, there are two things that has been changed. What are those? Kinetic energy and potential energy. Kinetic energy and potential. Therefore, due to this work done, due to this pressure difference, two works were done. What are those? Changing kinetic energy of that particle and changing potential energy of that particle. So, according to principle of energy conservation. So, according to principle of energy conservation, as per principle of energy conservation, I can say work done due to pressure difference, that means P1 minus P2 is equal changing kinetic energy plus changing potential energy. Changing kinetic energy plus changing potential energy. Did you get my point?
Yes, sir.
Thank you, Uday. Then I can write P1 minus P2. Changing kinetic energy. Changing kinetic energy means final kinetic energy minus initial kinetic energy. Final kinetic energy means kinetic energy per unit volume, because we are considering a unit volume. Therefore, final kinetic energy means half rho V2 square minus initial kinetic energy is half rho V1 square. This is the change in kinetic energy. Okay. Now, tell me what is a change in potential energy? Change in potential energy, tell me.
Rho G H2 minus H1.
Very good, okay. Rho G H2 minus rho G initial potential energy H1. Okay. Now, there are some physical quantities which is correspond to point A, V1, P1, so V1, H1 and P1 are corresponding to point A, and V2, H2, P2 correspond to point B. So if I take the factors correspond to point A to this side, then I can write P1 plus half rho V1 square plus rho GH is equal P2 plus half rho V2 square. I can take P2 is here, okay? Plus rho G H2. That means pressure at any point plus kinetic energy per unit volume plus potential energy per unit volume. Pressure at any point, pressure at particular point, plus kinetic energy per unit volume, plus potential energy per unit volume is equal to the pressure at another point plus kinetic energy per unit volume at that point plus potential energy per unit volume at that point. That means the addition of these three factors, is a constant. නොපුතේ නේද? මෙතන තියෙන මේවා addition එකයි මෙතන තියෙන මේවා addition එකයි equal කියලා කියන්නේ. මෙයා කොහෙන් කියත් මේක equal කියන එක. ඕනිම locations දෙක මේ addition එක equal කියන එක තමයි කියන්නේ. That means this factor, this addition is a constant. This is Bernoulli's principle or Bernoulli's equation. Okay, this is Bernoulli's equation. And Bernoulli equation means it is not another equation. It is the energy conservation law. Okay. Then I can write. That means pressure plus half V square plus rho GH is a constant. Is a constant. No, pressure is higher at P1 location. Pressure is higher at P1 location because fluid flows from here to here. Fluid flows from here to here, not here to here. And therefore, pressure is higher at this location. Therefore, work done by the pressure is equal to P1 minus P2. Okay, not P2 minus P1. And because this fluid flows from here to here. Here to here means pressure should be higher than that point and lower than that point. Therefore, work done by the pressure is equal to the P1 minus P2. Higher point to lower point. Okay. You can write that. You can write now. Yeah, it was not you. Okay. Yeah. Now you can clearly see. This one. Now this is the energy conservation. This is the energy conservation. So due to this energy conservation principle, actually the work done by this pressure difference, should be equal to these two parts only. That means this pressure difference, this pressure difference should be utilized to change kinetic energy and potential energy only. Otherwise, this equation is not valid. Did you get my point? Okay. So this equation is valid until this expression is valid. No, that means if the pressure difference is equal to the change in kinetic energy and change in potential energy, then this is valid. But if this pressure difference is used to do another works, then this will not be valid. Suppose this pressure difference is used to do work against fluid friction, that means against viscosity. There's a friction on fluid. There's a friction on fluid. So if this work done, if this work is utilized to do a work against fluid friction, then this equation is not valid. Okay. Suppose there's a turbulent, or if there's some rotational motion in fluid particles, then definitely there should be a energy required to do such kind of motions. Therefore, energy is consumed for such kind of motion. Therefore, if there is a motion, if there's a rotational motion or turbulent flow within the fluid, then this equation is not valid. Okay. Therefore, this equation is valid only if the pressure difference is used to change the kinetic energy and potential energy of fluid particles. Otherwise, this is not valid. Did you get my point?
Yes, sir.
So therefore, this is not valid for viscous fluid. This is valid only for non-viscous fluid. Because if there's a viscous fluid, this pressure difference, so therefore definitely there should be an energy to do a work against friction. Therefore, in such cases, this equation is not valid. And therefore, fluid should be a non-viscous fluid. Then the second point, there should not be any rotational motion or turbulent flow within the fluid. That means this should be a streamline, a steady state flow. Otherwise, this equation is not valid. Therefore, Bernoulli equation is valid only for ideal fluids. That means non-viscous, incompressible. If there is a compressible fluid, then definitely fluid can be compressed. To compress fluid, definitely there should be an energy. Therefore, that energy, the pressure difference, energy due to the pressure difference can be used for that scenario. Therefore, this fluid cannot be compressed. It should be an incompressible fluid. This fluid should not be a Therefore, this fluid should be a non-viscous fluid. If there is a viscosity, definitely some energy can be consumed to do a work against friction. Okay. And this should be a steady state streamline flow. That means laminar flow. Because if there is a turbulence within the fluid, definitely energy can be consumed for that curve. If so, this equation will not be valid. Therefore, this fluid should be a incompressible, non-viscous, steady state streamline flow. Did you get my point? I had the- Okay. Then write this one under the equation. Bernoulli's equation shows energy conservation, shows the energy conservation. Underline that word, underline that sentence. Compressible වුණොත් පුතේ compressible වෙනවා කියලා කියන්නේ මෙයා compress වෙනවා කියන සමහර fluids compressible නැහැ ඉතින්. බැරි වෙලා හරි compressible fluid එකක් තිබ්බොත් මොකද වෙන්නේ? දැන් අපිට මේක දාන්න පුළුවන් නේ මේවටත් අර මේ ඒ ආවලටත් උනත් කියන්න පුළුවන්. හරි ඒතර compress වෙනකොට මොකද වෙන්නේ? compressible වෙනකොට ඒ මෙයාගේ volume එකේ reduction එකක් වෙනවනේ. එතකොට volume change එකක් වෙනවනේ. volume change එකට අනිවාර්යෙන් energy එකක් තිබෙන්නේ. compress කරන්න පුළුවන් කියලා කියන්නේ volume change එකක් කරනවා. volume change එකකට අනිවාර්යෙන් energy එකක් ඕන. ඒ energy එක කවුද දෙන්නේ? මේ pressure difference. එතකොට මේ pressure difference එක නිසා ඒ එන force එක ඒකට choose වෙනවා. එතකොට මේක valid වෙන්නේ නැහැ. අන්න ඒකයි. තේරෙනවද ඍෂි? මොකද compressible කියලා කියන්නේ අනිවාර්යෙන් volume එක change කරන්න පුළුවන් කියන්නේ. compress කරන්න පුළුවන් කියන්නේ. volume එක change කරන්න පුළුවන් කියන එකේ තේරුම අනිවාර්යයෙන් ඒ force එක නිසා volume change එකකට energy එකක් මේ utilize වෙනවා. හරි. හරි. Right under another para, right under another para. Please listen very well. Please listen to me. Pute, please mention this equation as equation number 8. Please mention this equation as capital A. මේක පොළ පැහැදිලි වෙන පානේ මොනවද තමයි මේක මාක් කරගන්න. capital equation. Okay. අපි මේ වෙනම topic එකකට දාමු. Okay. Please write this as another topic. Validation of Bernoulli's principle. Bernoulli's principle. Validation of Bernoulli's principle. Okay, right on that. To validate Bernoulli's equation. Or Bernoulli's principle, Bernoulli's principle. To validate Bernoulli's principle. The equation A, the equation capital A has to be fulfilled. Has to be fulfilled. Therefore, 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 the provided energy by the pressure difference, therefore, the provided energy by the pressure difference should be utilized, should be utilized should be utilized only to change kinetic energy and potential energy.
So is the fluids lesson over from today? Like the theory?
Yes, the theoretical part is over, Pradeep. Now actually now it is over. And but we have discussed questions. We have discussed questions. That means when we are discussing questions, we have to discuss some applications part. Otherwise, the theoretical part is over. Okay.
Okay, so that does that mean that we are gonna start waves and oscillations after that?
Yes, waves and oscillations. Okay.
Okay, sir.
Mm, okay. Then write on that. Therefore, therefore, if the provided energy, if the provided energy is used to do another works this equation will not be valid. This equation will not be valid. Oh, take a rotational motion. Torque क्या करना है rotational circular motion ने torque क्या करना है अभी लग रहा है rotational motion rotational motion එකයි අපිට කොහොමද අපි lessons තුනක් යනවනේ rotational motion එකයි ඊට පස්සේ waves පානමයි ඊළඟට field lesson එක electricity field පටන් ගන්නවා ඊළඟට heat lesson එක කොහොමද හරි ඒ ටික තමයි යන්නේ ඒක එන විදිය බලමු කියලා කියන්නේ මොකද දැන් මේ අද lesson එක ටිකක් මේ දිග lesson එකක් නිසා මේකේ අද classes එන්න බැරි වෙච්ච ළමයි ඉන්නවා classes එන්න බැරි වෙච්ච ළමයි හිටියොත් එහෙම මේ විතර පොඩි ප්‍රශ්නයක් එනවනේ එතකොට මේ ළමයිට එකක් තියෙනවනේ මේ recording එක බලන්න time එකක් දෙන්න නැත්නම් එතකොට ඊළඟ දවසේම ආයෙසර fluid applications කරොත් එතකොට පොඩි ප්‍රශ්නයක් වෙනවා ඒක පොඩක් ළමයිට කියලා එතකොට අපිට ඊළඟ දවසේ අපි අලුත් lesson එක පටන් ගන්න ඊට පස්සේ week එකේ ආයෙසරක් මට fluid කරන්න පුළුවන් නැත්නම් අපිට හැබැයි Saturday Sunday එක එහෙම තමයි කරන්න වෙන්නේ නැත්නම් heat lesson එක ගන්න වෙනවා Monday class එකට මේ week එකට විතර හරි එහෙම මාකර් දෙට්ටව කරන්නේ බස් හරි පුතේ අපි ඒක කතා කරලා අපි ක්ලාස් එක ඉවර කරනවා ඔව් වෙලා okay what is the last sentence පුතේ
Therefore, if the energy provided is used to do other work, this equation will not be valid.
okay write some examples number 1 if the energy is used to do if the energy is used 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 to do a work against friction to do a work against fluid friction if the energy is used to do a work against fluid friction the equation will not be valid. Number 2. If the fluid is a compressible fluid, if the fluid is a compressible fluid, if the fluid is a compressible fluid, some portion of energy can be utilized to change its volume. Number 3, if the fluid is a turbulent flow, if the fluid is a turbulent flow, there will be a there will be there will be there will be a loss of energy due to collisions between particles. Due to collisions between particles. Right under that, right under that. Therefore, therefore, if the Bernoulli's equation is valid, if the Bernoulli's equation is valid, is valid, then, then, then the fluid should be number 1, non-viscous, number 2, incompressible, number 3, streamline, steady state. Streamline, steady state flow. Okay. Hello. Actually, when we are applying Bernoulli's principle, okay, we have to choose a streamline. We have to choose a particle on a streamline. Okay. Actually, we have considered a unit volume with it. So when we are deriving the equation, we have used a unit volume. Therefore, when we are apply the Bernoulli's equation or Bernoulli's principle, first we have to select a streamline, then we have to select a particle on this streamline. Then if this particle moves from here to here, then we can apply Bernoulli's principle from to this point and this point. Okay, so we have to consider a particle on a streamline when we are applying Bernoulli's equation. Okay, that's why I draw a streamline in my previous drawing. And okay. So actually, we cannot apply Bernoulli's equation on two particles in two different streamlines. Actually, this is an energy conservation rule. So you have to conserve energy of any object. So in this case, the object is fluid particle. Fluid particles flows on a streamline. Therefore, if you select a fluid particle, you have to consider that fluid particle only. You cannot consider two different fluid particles, because in two different fluid particles, energies are not equal to each other. No? Yeah. Therefore, this is energy conservation law. Therefore, if you apply, when you are applying Bernoulli's equation, you have to select a fluid particle. Then you have to conserve energy of this fluid particle at two different locations. As this is a streamline flow, normally fluid particle flows on a streamline. That's why I select a streamline and select two different locations of this streamline. And because fluid particles flows on a streamline. Did you get my point? energy conservation එක දානවා නම් ඔයා අනිවාර්යෙන් ඔබ්ජෙක්ට් එකක් සිලෙක්ට් කරගන්න ඕනි. හරිද? ඔබ්ජෙක්ට් දෙකක එනර්ජිස් ඉක්වල් කරන්න බෑ. මෙතන තියෙන පාටිකල් එකකයි මෙතන තියෙන පාටිකල් එකකයි එනර්ජි ඉක්වල් කරන්න බෑ. ඔයාට ඒක කරන්න බෑ නේ. හරිද? එනර්ජි එක කන්සර්ව් කරන්න ඕනි සිංගල් පාටිකල් එකේ. හරිද? ඒක නිසා ඔයා මෙතන පාටිකල් එක සිලෙක්ට් කරගත්තා නම් එයා මෙන්න මෙතනට එනකොට තියෙන එනර්ජි එක තමයි බලන්න. හරිද? පාටිකල් එක කියන්නේ ස්ට්‍රීම්ලයින් එකනේ. එහෙනම් අපි මොකක් කරේ ස්ට්‍රීම්ලයින් එක two different locations තමයි ගන්නවා. හරි? ඒ නිසා ස්ට්‍රීම්ලයින් දෙකක ලොකේෂන් දෙකක් එහෙම ගන්න එපා. ස්ට්‍රීම්ලයින් දෙකක එකම පාටිකල් එක තියෙන්න බෑනේ. ස්ට්‍රීම්ලයින් දෙකක එකම පාටිකල් එක තිබ්බොත් ඒක ස්ට්‍රීම්ලයින් ෆ්ලෝ එකක් වෙන්නේ නැහැ. හරි? ඒක නිසා කවදාවත් අපිට ස්ට්‍රීම්ලයින් දෙකක එනර්ජි කන්සර්ව් කරන්න බෑ. Bernoulli's equation එක දාලා එක වැරදි එක කරුත් එහෙම. හරි? ඒ නිසා හොඳට ඒක මතක තියාගන්න සමහර වෙලාවට ඔය ගමන් හදනකොට අර උඩටයි යටටයි එන Bernoulli's දානවා කියලා සමහරවට දානවා මෙලෝ මනෝදානයක් මේ තේරුම් ගන්න තු කරන වැඩක් ඒක. හරිද? සමහර දැන් තියෙන අපිට එක්ස්කේප් වෙන්න තැන් ඒවා හේතු ඇතුව තර්කානුකූලව කරන්න ඕනේ. හරිද? මම ඒකයි කරන්නේ මේ Bernoulli equation එක valid වෙන්න මොන වගේ fluid වලටද කියලා ඕන නිකන් කියන්න තිබ්බා. මේක valid වෙන්නේ non viscous මේ incompressible මේ ඊළඟට steady state flow වලට කියනවා. හැබැයි ඒක වෙන්නේ කියලා වලට කියලා දෙන්න. ඔන්න වෙන්නේ හේතුවත් එක මම කියනවා. එතකොට පුතේ ඔයාලා අනිවාර්යෙන් කටපාඩම් කරගන්න ඕනේ නැහැ. හරියට point එක දාන්න. හරියට point එක දාන්නහම මාරු ලේසි වැඩේ කරන්නේ. හරි? ඒක මම කියන්නේ මෙතන මේකත් හොඳට මතක තියාගන්න මේ එනර්ජි කන්සර්වේෂන් ලෝ වෙන කිසිම දෙයක් නෙමෙයි මේ එනර්ජි කන්සර්වේෂන් ලෝ මතක තියාගන්න ඔබ්ජෙක්ට් දෙකක එනර්ජිස් කන්සර්ව් කරන්න බෑ තනි ඔබ්ජෙක්ට් එක වෙන්න ඕනේ තනි ඔබ්ජෙක්ට් එක ලොකේෂන් දෙයක් වෙන්න තනි ඔබ්ජෙක්ට් එක ලොකේෂන් දෙයක් වෙන්න ඒ නිසා හොඳට තේරුම් ගන්න මම කිව්වේ පැහැදිලිද ඕකේ මොකක්ද අශින් හොල්පේ Okay. අපි මේක ලියාගත්තනේ. අපි ඒක ස්පෙෂල් නෝට් එකක් දාලා ඉදිරියට දාගමු. write a special note today. Write a special note. අපි note එකේ point කීපයක් දාගමු. Point number 1. Point number 1. The same particle is there. Same particles, rule of reference. Draw this one. Fluid එකේ viscous පුතේ viscous fluid වලට මේක දාන්න බෑ. Viscous fluid වලට මේක දාන්න බෑ. හරි? Viscous fluid වලට මේක දාන්න බෑ. Viscous fluid වලට අපි වෙනම මේ විදිහෙන් මේක අපි ඉවලුවේට් කරන්නේ. Viscous වලට මේක දාන්න බෑ. ඒ නිසා මේකේ viscosity එකක් තියෙනවද නැද්ද? අපිට එක දාලා මේක viscosity එක නැති වෙන්න ඕනේ මේක දාන්න. හරි? Viscosity එකක් තියෙනවා නම් ඒක අපි දැනගෙන ඒ අනුව ඒකට යන මේ force එක අපිට වෙනම හොයන්න පුළුවන් viscosity කරාට පස්සේ ඒ අරමුණම viscosity දිදී බර්නල් දාන්න බෑ. අර equation එක විතර අර equation එක වලින් නැත්තම් බර්නල් දාන්න බෑ. හරි මම එකක් හැම වෙලේම අර equation number A අන්න ඒක ඔලු තියාගන්න. equation number A කියන එක අනිවාර්යයෙන් valid වෙන්න ඕනේ බර්නල් true වෙන්න. Okay, draw this one. Okay. They write on this. Wait up. They write on this. Bernoulli equation shows the energy, the principle of energy conservation. Bernoulli's equation shows the principle of energy conservation. When applying the principle of energy conservation, we should select an object. Or system
Sir, excuse me, could you repeat that sentence, please?
when applying the principle of energy conservation, when applying the principle of energy conservation, we should select an object or a system. Then principle of energy conservation, that PEC here. Short form. Then the energy of that particle, the energy of that particle the energy of that particle in two different location, in two different location, in two different locations will be considered, will be considered. Therefore, we cannot conserve, we cannot conserve energies of two different objects. We cannot conserve energies of two different objects. We cannot conserve energies of two different objects. Part under that, part under that. Therefore, when applying Bernoulli's equation, when applying Bernoulli's principle, therefore, when applying Bernoulli's principle, we have to select two different locations in the same streamline. We have to select two different locations in the same streamline. Underline that too. Point on that. Because a fluid particle in a streamline flow, because a fluid particle in a streamline flow flows along a streamline. Did you get my point?
Yes, sir.
සමහර දැන් තියෙනවා පුතේ මේක සමහර වෙලාවට අපිට මේ අර වෙනස්කම් නැතන් තියෙනවා. ඒ කියන්නේ ගොඩාක් අර නිග්ලෙක්ට් කරන අවශ්‍යතාවන් තියෙනවා. ඒ වගේ දැන් අපි හරියට බලලා ඒක කියලා ඒ නෝ කරන තමයි කරන්නේ. Okay. Then the second note again number 2. Okay, suppose a horizontal streamline. If we consider a streamline which is in the horizontal direction. Now this is a horizontal streamline. Okay. Plot it can be it can be any shape. It's something like this. Okay. Tip-top can be any shape. This is a horizontal streamline. Okay, so if I select two different locations in a horizontal streamline, then the height to the potential energy zero level. The height to the potential energy zero level is same, no? It is equal in each case, ne? So if we consider two different locations on a horizontal streamline, definitely the height to the potential energy zero level is equal. Okay. So therefore, rho G, that means potential energy per unit volume. Potential energy per unit volume is equal in each case. Okay. So then I can write Bernoulli's equation. If I apply Bernoulli's equation in these two locations, suppose this one, then I can write PA plus half rho VA square plus rho GH is equal to PB plus half rho VB square plus rho GH. Then you can clearly see rho GH to rho GH will be cancelled out. It will be cancelled out. So definitely it is very clear P plus half rho V square that is a constant. So in a horizontal streamline, for a horizontal streamline, P plus half rho V square is a constant. Therefore, for a horizontal streamline, we can write the Bernoulli equations as P plus half rho V square. P plus half rho V square is a constant. And අපි horizontal streamline එකක් නම් මට කෙලින්ම Bernoulli equation එක ලියන්න පුළුවන් without rho GH. Okay. So that's the second important part. Write down that thing. Number two. Number two. Madam. ඉතින් මෙතන ඉඳ තියෙනවා නම් පොඩ්ඩක් ලියා ගන්න මේ මට කියන්න බැරුණා නේද ස්ට්‍රීම් සයිස් දෙක තියෙනවා ලොකේෂන් දෙක දාන්න බෑ කියලා මම කිව්වේ නෑ නේද? Hmm? In the first note, I think I did not mention that we cannot apply Bernoulli equations for two locations, two different streamline. We haven't write that, no? We will anything.
Sir, I'm experiencing connection issues. Did you say something?
Yes, with them, because actually I have to mention that we cannot apply Bernoulli equations for two locations in two different streamlines. I think we haven't not that thing, no?
We did.
We did.
We did. Yes.
Okay. Thank you. Agree. Okay, right on this, right on this. Therefore, therefore, rho GH term can be neglected, for a horizontal streamline, Everyone, please look at the board. This is the very, very important explanation for it. Actually, this is the co-explanation in Bernoulli's principle. Look at this one. P plus half whole V square is a constant. You know the density of the liquid is a constant. It is not going to change. And therefore, there are only two variables. One is pressure, other one is velocity. One is pressure and other one is velocity. The addition of those two is a constant. So when the pressure increases, this one velocity should be decreased because the addition should be a constant. To keep that equation as a valid equation, when the pressure increases, this term has to be reduced. So in high pressure location, the velocity of fluid decreases. Okay. So when the pressure decreases, definitely this term has to be increased. That means velocity increases. So this is the co-explanation in Bernoulli's theorem. Bernoulli's theorem එකේ අපිට explain කරන්න තියෙන co-explanation එක අපිට වෙන්නේ when pressure increases, velocity decrease. When pressure decreases, velocity increase. Okay. Therefore, in some location, if we consider about a location where the pressure is high, then the velocity of that fluid flow should be at a lower level. If we consider about location where the pressure decrease, so that means where the pressure is at a lower value, then definitely the fluid flow, the velocity of that fluid flow has to be at a higher value. Okay, that is the thing. And right under this note put note number 2 as for the above equation, it is very clear when pressure increases, then velocity decreases. And vice versa. You can write this one in. Okay, okay. Then the note number 3. Okay, in Bernoulli's equation, there are three terms, no? One is P plus rho GH, rho GH plus half rho V square is a constant. So this is the Bernoulli equation. Okay. So in this equation, this part, pressure plus H rho G or rho GH is called the static pressure. The static pressure. This part is called the static pressure. And this part, half rho V square, this part is called the dynamic pressure. Dynamic pressure. Is called dynamic pressure. This part is called the static pressure. This one is called the dynamic pressure. And you can simply understand, simply memorize. You know the static pressure. Static pressure is P plus H rho G. P means pressure at the point plus H rho G again. So this part is called the static pressure, and this part is called the dynamic pressure. Okay. The addition of static pressure and dynamic pressure. The addition of static pressure and dynamic pressure is called the total pressure of that fluid flow. The total pressure of that fluid flow. Okay. Therefore, the total pressure of a fluid flow is equal to the static pressure plus dynamic pressure. The static pressure plus dynamic pressure. Okay. So in some questions, within some questions, sometimes you are given static pressure and dynamic pressure. Okay. In such kind of questions, it is not mentioned about pressure and about that means about kinetic energy or potential energy. They are not mentioned. But sometimes you are given static pressure and dynamic pressure. So if you know these terms, then you can apply that term into the Bernoulli equation. Okay. Okay. So this is the total pressure. Total pressure. And static pressure and dynamic pressure. Simple total is equal P static plus P dynamic. P static plus P dynamic. This is the formula. Okay. All right. Do you have any questions regarding this up now? Do you have any questions? Hmm? No. Thank you. Others? Anita? තියෙනවද අකුලේ? Malki, Virishaka? Okay, we can complete today's class today because from next week we have to do some questions. Questions means we have to do some applications as well. So I think it is better to pass it with all these students for that class today. Otherwise, there will be some complicated application. There will be some complicated applications, but basically the principle is relatively easier theory part. But when we are doing applications with it, there are some special cases. So you have to practice this way. ඒ වගේ අර ස්පෙෂල් කේසස් තියෙනවා. ඒ වගේ ප්‍රැක්ටිස් කරන්න නැතුව කරන්න බැරි දෙයක් නේ. හරි. There are some theoretical part to take. If you know the theoretical part, then you can apply the theoretical part to the questions without any doubt. Okay, but in Bernoulli's equation, you have to practice that one because there are some special cases. There are some special cases when we are applying Bernoulli equations to a question. Again, velocity එක 0 කරලා තැන් තියෙනවා. ඊළඟට අපි streamlines consider කරන systems තියෙනවා පුතේ. එතකොට questions කරනකොට තමයි අපි ඒවා හුරු. ඒ නිසා මේකේ questions ගොඩක් කරන්නත් ඕනේ. හරිද? ඒ නිසා next day එක තනිකරම full question දෙකක් වෙනවා. ඒ questions කරන ගමන්ම තමයි applications කතා කරන්නේ. නැත්නම් තේරෙන්නේ නැහැ ඕගොල්ලන්ට. applications එක ඉගෙන තියාගෙන කියන තේරෙන්නේ නැහැ. questions කරන ගමන්ම තමයි applications කතා කරන්න ඕනේ. එතකොට questions කරන ගමන්ම මේකේ තියෙන real time, ඒ කියන්නේ practical applications එක කතා කරන්නේ. හරිද? එතකොට එතනින් අපිට fully අපිට complete කරන්න පුළුවන්. දැන් theoretical part එක ඉවරයි. theoretical part එක ඉවරයි. ඊට පස්සේ අපිට fully ඉවර කරන්න ඉතින් අපි questions කරලා EQR එක කරන්න ඕනේ. EQR කරාට පස්සේ තමයි ඒක fully complete වෙන්නේ. එතකොට දැන් ඕගොල්ලන්ට ඕනනම් try කරන්න පුළුවන් අර මම කියපු ටියුට් එක try කරන්න. හැබැයි ඉතින් මම questions කරනකොට මම ඒක කියා දෙනවා. හරි? Okay. We can complete today's class with it. Do you have any questions regarding Bernoulli's equation?
No, sir.
Thank you. Okay, okay. Okay, please look into the theoretical part again. Then coming to the next class. Next class means day after tomorrow, Sunday class. Sunday class means we will do rotational motion on Sunday class, okay? Right? In Sunday class, okay? Right? Hi, Hena, you can complete today's class with it. Then, everyone. I want to say good night. Good night.
Thank you, sir.
Okay.